we present DF3DV-1K, a large-scale dataset and benchmark for a distractor-free novel view synthesis. Over the years, radiance fields have demonstrated the ability to synthesize photorealistic novel views from multi-view images. Several variants, such as NeRF in the wild, have been developed to handle multi-view images collected over large temporal gaps, while dynamic radiance fields have been introduced to represent 4D scenes. Among these variants, distractor-free radiance fields stand out for their ability to render clean novel views from casually captured images. Such images, typically collected within a short time span, often contain transient distractors that can break multi-view consistency. However, the existing datasets and benchmarks for distractor-free radiance fields are limited in scale. They typically contain only indoor scenes, include a limited variety of distractor types and scenarios, or consist of cross-domain data that lack clean views for benchmarking. Therefore, it becomes difficult to identify the strengths and limitations of recent state-of-the-art methods. In addition, progress from scene-specific methods toward generalizable solutions is hindered. Therefore, to address these issues, we propose the Distractor-Free 3D Vision 1K DF3DV-1K dataset and benchmark. DF3DV-1K contains 1,000 scenes manually collected over 9 months. Each scene provides both clean and cluttered images, covering more than 100 distractor types and themes. We further systematically designed a smaller subset, DF3DV-41, which contains 17 scenarios. We benchmark vanilla 3DGS and 9 recent distractor-free radiance field methods on DF3DV-1K to evaluate their generalizability and robustness. The DF3DV-1K benchmark shows that ASIMGS and robust splat are the most robust methods, followed by OC splats and DeGauss. Interestingly, the method ranking on DF3DV-1K roughly follows the publication timeline, reflecting a consistent and reasonable progression in performance as more recent methods continue to advance the field. To enable systematic analysis, we further designed DF3DV-41, which includes 17 scenarios based on our observations of the weaknesses of current distractor-free radiance field methods. Quantitative results show that semantically similar and fluid distractors are the most challenging scenarios, while nighttime scenes are the most difficult scene type. For semantically similar distractors, many methods rely on semantic features for distractor identification. When distractors share similar semantics with static objects, they become difficult to distinguish. For fluid distractors, online mask learning struggles with scattered and semi-transparent phenomena, often removing valid scene content or leaving residual artifacts. For nighttime scenes, fixed threshold-based filtering methods become unreliable under low illumination, making it harder to separate distractors from static scene components. The challenging scenes provide zoom and no more qualitative results for method comparison. Beyond scene-specific methods, we introduce DSquareFix, distractor-free DFix, by fine-tuning DFix on DF3DV-1K with minimal modifications to enhance the rendering quality of distractor-free radiance fields. The quantitative results show that DSquareFix can improve the rendering quality of 3DGS and 9 recent distractor-free radiance field methods by an average of nearly 1.0 decibels in PSNR and 0.06 in LPIPS. The qualitative results further validate these improvements. This demonstrates the significance of the DF3DV-1K dataset. Although DSquareFix demonstrates the ability to improve rendering quality, it may fail in cases where the reference view is overly noisy or contains confirmation bias. Adapting a multi-reference framework may mitigate this issue. In summary, we propose DF3DV-1K, a large-scale real-world dataset containing both clean and cluttered images for each scene. We construct the DF3DV-1K and DF3DV-41 benchmarks, comprehensive benchmarks for evaluating distractor-free radiance field methods under diverse distractor and scene conditions. We introduce DSquareFix, a plug-and-play enhancer that improves the rendering quality of distractor-free radiance field methods. Please visit our project page for the paper, Dataset, Code, DSwearFix Demo, and Leaderboard. Additionally, we are happy to announce that DF3DV Extra is now available, providing an additional 1,000 scenes for distractor-free research.